Good morning everyone. See, today we are going to discuss the IIT-JEE NEET foundation, the light concepts. See, light is an electromagnetic wave. Light is a transverse wave. Light is emitted from the self-luminous bodies. There are two types of bodies, self-luminous and non-self-luminous. Self-luminous is nothing but the body which emits light by itself is called self-luminous. Non-self-luminous, the bodies which emit light but they depends upon the self-luminous bodies. They are called non-self-luminous. Self-luminous bodies, example sun, etc. Non-self-luminous bodies, example moon and all objects like stone, wall, all these are non-self-luminous. Basically light, the chapter of light, it is optics, study about light and its phenomena. See, usually in all other chapters the phenomena will be experimental phenomena and other things will be there, but in the case of the light, observed phenomena will be there. See, since we are observing the light, see, there is a reflection, refraction, so interference, see, diffraction, etc. These are all the phenomena are just observed phenomena. Basically the study about light is study about phenomena only. Study about light is nothing but study about phenomena. So in the case of the light, we have, see, there are different concepts like the propagation of the light. See, if you go to the light and vision, if you take the propagation of the light. See, the propagation of light is nothing but the light is an electromagnetic, it's a part of an electromagnetic spectrum. In the electromagnetic spectrum, the visible light is 0.4 micrometer to 0.7 micro, VIBGR, violet, indigo, blue, green, yellow, orange, red. So that electromagnetic spectrum, see, it's a part of electromagnetic spectrum. In the electromagnetic spectrum, there are different rays, that is the visible spectrum. Visible spectrum will be there. So the visible spectrum, we have, see, with naked eyes we can observe this, that is about 400 nanometer to 700 nanometer. Next, light is an and it is emitted from the self-luminous bodies. I told you already, light is emitted from the self-luminous bodies, and the speed of the light, important characteristics, light is a transverse wave. It travels with a speed, it is 3 lakhs kilometers per second, approximately the value 299,792 plus or minus 1.2. See, how to find the speed of the light. See, speed of light is an light is an electromagnetic wave. There is electromagnetic properties are going to consider here. One is called mu naught, another is called epsilon naught. See, the mu naught and epsilon naught, if you take these two values, see here, this is the important formula. C equal to 1 by mu naught or epsilon naught. C equal to 1 by square root of mu naught or epsilon naught. Mu naught is nothing but the magnetic permeability. It is a permeability in the free space. The mu naught value is 4 pi into 10 power minus 7 Henry per meter. And epsilon naught value, it is 8.85 into 10 to the power of minus 12 Coulomb square by Newton meter square. So this is the epsilon naught value and mu naught value. By using these values, you will get the speed of the light. The speed of light. So there is some speed of light. Of course, there is a speed of light is there is certain algebraic equations also. So 1 by square root of 1 minus v square by c square. This is also important formula because the light is the speedest. If object is more than the speed of the light, if the object speed is more than the speed of the light, there we have to use these type of formulas. So then these calculations should be done. Of course this is behind your syllabus. See, coming to the, so the speed of light is equal to nu lambda. Nu is nothing but the frequency and lambda is called wavelength. See, this formulas if you observe here, for example, if you take lambda value, see the lambda value and frequency, if you take it as how much energy light is going to be emitted according to the Planck's quantum theory, quantum energy is nothing but E is equal to h nu. E is equal to h nu. See, for example, the nu value, if you take the nu value, frequency, nu is nothing but frequency. See, 20 into 10 to the power of, see for example 5, 10 to the power of 5 hertz. The frequency is 0.02 kilohertz. The energy is this much, 0.87 into 10 power minus 13 electron volts. See, this is the frequency value. The frequency value, if you change here, for example, the frequency is changed. See, the frequency is, let us say 2000. See, when the frequency is 2000, then what will be the value? Let us take that frequency is something, you take it as frequency. See, there is 4500 hertz. Then electron volt value 1.86 into 10 power minus 10 power minus 6 electron volts. This is the quantum energy. See, it depends upon the, see, frequency. The light having a frequency, E is equal to h nu. So that h nu is the frequency here, h is the Planck's constant. What is the Planck's constant value? It is 0.023 into something 6.10 power minus 36 into 10 power minus 34 joule second. So that based on that value you can calculate this. And coming to the, see, if it is a frequency is 4500, then lambda will be this value. Lambda is nothing but wavelength. Since the speed of light is constant, then you can get the value of lambda also. See, the lambda value, let us take here, the frequency is 4500. Frequency is 4500 into, so 10 power minus 5 we have taken. So that is hertz. If you know the frequency, then lambda is equal to, see, V is equal to n lambda, or C is equal to nu lambda. So lambda is equal to C by nu. C is nothing but 3 into 10 power 8 into 10 power, see, 4500 into 10 power minus 5. So in this way you can calculate the values. And for example, you take here, there is some lambda value. See, some lambda value you take here. If you take lambda value, yes, you take lambda value is something 100, you take lambda is 100. So into 10 power 0 only you can take 100 meters. That is, what will be the electron volt? If you take lambda is 100, so the frequency becomes 3. How frequency becomes 3? See, lambda is equal to, just now I told you, lambda is equal to C by mu. Lambda is nothing but, you can take it as lambda, C is equal to nu lambda, C by nu. But you want mu is equal to C by lambda. C is nothing but 3 into 10 power 8 and divided by 100. So it means 3 into 10 power, see some value, that 100 is 10 power 6. 3 into 10 power 6 you are going to get. If you observe here, see, 3 into 10 power 3000 kilohertz, that means 3 megahertz. 3 into 10 power 6, 3 into 10 power 6, okay, so hertz. In terms of gigahertz, it is in terms of gigahertz 0.003 gigahertz. In centimeters, 1 by centimeter, the frequency 0.001. The energy h nu is equal to hf, otherwise the frequency you got it is see 3 into 10 power 6. See, in that way you can convert. So the values of wavelength is lambda. Light is having a wave, because light is a transverse wave, it is a lambda value will be there and frequency will be there. So by using all this you can find out the energies, because light is nothing but it is an electromagnetic wave. Light is an electromagnetic wave which is having all the characteristics of wave, like wavelength, frequency, and the speed of light, the speed of wave, etc. These are all will be there for the light also. See, the propagation of the light, speed of light is 3 into 10 power 8 meters per second. Yeah. In the light vision, we have another important one, reflection. What is meant by reflection? Reflection is a phenomena. See, the bouncing of light. So from the surface where light is incident, means it returns back to the original medium. When a light is incident on any particular medium or any particular surface, it returns back to the original medium, or bouncing back of light is called reflection. So light is incident upon the surface, it will be generally partially reflected, partially transmitted, see, partially refracted. Light is, so reflection will be there, refraction will be there, transmission will be there. All these three factors will have the see, when light is passes through any medium, so there is a reflection, refraction, and all the properties will be there. That's why you have to carefully, we have to take reflection. See, in the case of the reflection, and mirrors you take. In basically mirrors are going to be the widely used optical instrument to have the reflection. So the reflection phenomena, you take the, see, there is a mirror which is convex mirror you take. If a convex mirror is there, see, what is convex mirror? See, this is the convex mirror. Here if you observe carefully, in the case of the convex mirror, see, let us take this convex mirror. Here if you observe the mirror, this is the mirror. If you take the mirror surface and curved surface, the reflecting surface, this part is the reflecting surface. See, the part what we are observing, see here, this part is the reflecting surface. See, but usually for the mirror there is a center of curvature will be there. The center of curvature, see, the center of curvature will be the other side. This is the center of curvature or focus, etc. Center of curvature, focus, etc. will be there. If you observe carefully, see, the reflecting surface is other side of the center of curvature. Reflecting surface is other side of the center of curvature. So, and this is the colored surface. This surface is colored surface. The colored surface is towards the center of curvature. See, such mirrors are called convex mirror. In front of the convex mirror, if an object is placed, so light ray is coming from the object which is parallel to the principal axis. This one is called the principal axis. This line is called the principal axis. And this ray, the light ray which is see, the light ray which is parallel to the principal axis. The light ray which is parallel to the principal axis, after incident on the mirror, okay, it reflected back like this. That reflected ray passes through the, see, the passes through the principal axis at some point, that is called focus. We will call it as a focus. And the another light ray which is incident on the mirror and reflected back like this. So here the reflection, here whatever the reflection, the reflected ray if you extend and another reflected ray if you extend, they meet at one point, their image is going to be formed. The image is going to be formed there. So it means, see, you can understand, this is the object which is there in front of the mirror, and this is the image. See, object is this image. The distance between image to the mirror is called image distance, that is denoted by V. The distance between image to the mirror is called image distance. The distance between object to the mirror is called object distance, that is denoted by U. See, these are the two important things. And the object, if it is, see, if object is above the principal axis and image is also above the principal axis, so such images are called here. See, it is a virtual erected image. Virtual because the image is formed inside the mirror and the image is formed by the reflecting, okay, see, something like see, diverging rays. The image is formed by the diverging rays, that is called virtual image, and it is formed inside the mirror. It's a virtual image. Virtual images are erected images. Convex mirror forms erected images, virtual images. That you have to remember. That is a very, very important point. See, coming to the next, that is concave mirror. In the case of the concave mirror, we have the reflecting surface is towards the center of curvature. Here if you observe, see, this is the reflecting surface. The reflecting surface is towards the center of curvature. Object is there in front of the mirror. So there is a focus will be there. So let us, this is the focus. And there are so other points like, okay, so whenever the colored surface is other side of the colored surface, this will be the colored surface. If you take, this is the colored surface. This part is colored surface and this one is the reflecting surface. Here reddish one is the colored surface. Colored surface is other side of the focus or center of curvature. Then such mirror is called concave mirror. Object is there in front of the concave mirror. So this object forms image. See, for example, the light ray which is see, parallel to the principal axis, after incident it will be reflected back. The reflected light ray which passes through the principal axis at focus. So and another light ray which is passes through the focus and which is returns back in the same. See, which is once if it passes through the focus and it will be reflected parallel, of course. See, that what we will call, if a light ray passes through the center of curvature, of course this is the center of curvature. So when light ray, okay, see, passes through the center of curvature, it reflected back on the same line. If the light ray passes through the focus, after incident it comes as a parallel to the principal axis. These points you have to remember, don't get confused. Yeah, see, if a light ray passes through the center of curvature, this is the center of curvature, after reflection it will be returned back to the same path. If the light ray, another point, important point, if a light ray passes through the focus, this is the focus, it returns, okay, so parallel to the principal axis, it returns parallel to the principal axis. So these points you have to remember in the case of the, see, mirrors. See, basically the object is there, see, beyond the center of curvature. If object is there beyond the center of curvature, so what type of image is going to be formed? Because the rays are here converging rays, those converging rays forms a real image, real inverted image is going to be formed. See, if object is beyond the center of curvature, it is a real inverted image is going to be formed for the concave mirror. See, that is the first case. Let us take, see, another case. This is, now object is there at the focus. If object is there at the focus, the image where it is going to be formed, image is formed inside the focus, there is image is formed in, see, inside the mirror. If it is object is at the focus, image is formed at infinite. Image is formed at infinite. So this is inside the focus. That's why the image is formed here. This is the image and this will be the object. Due to this, it's a virtual erected image is going to be formed. Virtual erected and magnified image. See in the if you observe convex mirror, it is also virtual image, but this virtual image is erected and diminished image. The size of image is less than the size of the object in the case of the convex mirror. But in the case of the concave mirror, the image is so it is a magnified image, enlarged image. The image size is greater than the object size. Image size is greater than the object size. These points you have to remember carefully. Don't get confused with the points. Yeah. Here, in the case of convex mirror, if you take, this is another, just we'll go back to that. So reflection mirrors, here this particular slide, object inside the focus and the mirror instruments. See the mirror instruments, these are the mirror instruments basically. So the mirrors, different systems we are going to use, of course this is beyond your course. Coming to the mirror concepts. In the mirror concepts, mirrors basically it works under the law of reflection. So there are mirrors are going to be law of reflection. What is law of reflection? There are incident ray and reflected ray and normal, all are lie in the same plane. Incident ray, reflected ray and normal lie in the same plane. Second law, the angle of incidence is equal to angle of reflection. See in some books third law also will be mentioned. The incident ray and reflected ray are lie on either side of the normal or lie on either side of the normal. Of course convex mirrors, just now we discussed convex mirror. So the convex mirror, this is the basically convex mirror. The focal length is negative, virtual image is going to be formed, and the formula 1 by object distance plus 1 by focus is equal to 1 by image distance. That all is taken in the yes. If you observe here the entire mirror concepts, in the mirror concepts, convex mirrors, O is the normally negative because it is measured from the sign conventions are also important in the mirrors. If you are taking the left side of the mirror, that should be taken as negative. Right side of the mirror should be taken as positive. That points you have to understand. Here the I value is negative because the I is nothing but here negative for the virtual images. For virtual images should be taken, the sign conventions you have to be careful. O is normally negative because it is measured from the left of the surface against the light direction. That's why you have to take object distance is negative here, image distance is positive. Of course for the virtual images we have to take the ray diagrams for the mirrors. These are the ray diagrams just now we discussed. See, coming to the mirror concepts. In the mirror concepts, concave mirror. So the concave mirror object is there. So in front of the mirror, the image is going to be formed. It's a real inverted image is going to be formed. So the ray diagram for mirrors, the same thing. Length. So these are the mirror concepts. Coming to the The mirror instruments, these are different mirror instruments like telescopes, telephoto lenses, and catoptric systems, catadioptric systems. And there is a principle which is used in the law of reflection, Fermat's principle. We'll discuss later. The mirror equation. See, 1 by object distance plus 1 by focus is equal to 1 by image distance. So the focal length f equal to r by 2. R is equal to 2f. Important. See, Cartesian sign conventions we discussed. All the figures are drawn from the light traveling from left to right. All distances should be measured from the reference surface left, reflecting surface. Distances left should be taken as negative. The refracting power which makes the focal length is positive. You have to take like that. The distance of the real object is negative. The distance of real image is positive. The distance of real image is positive. Real object is negative. And heights above the optic axis is positive. Heights below the optic axis is negative. See, these sign conventions you should take very carefully. You should apply. So for even lenses also the same type of sign conventions will be there. Of course, the mirror formula, image distance, object distance, you can calculate the things. Here for example, focal length if you give, what will be the, see, focal length is, for example, you take 100. The focal length of the lens or mirror you can take. Okay, so then power will be 1 diopter. Power will be 1 diopter. If it is object is, of course this will, okay, so these formulas and all lens concepts it is coming. Okay, we'll discuss that thing so later. So this is about the reflection of the mirrors, etc. So thank you very much. Thanks for watching the video.